Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire, and today we've got Jose who has just completed the course Linux Basics, and he'll be giving us a presentation on that. So first of all, we'll begin by seeing his code base running on the real robot, and then after that we'll get into the details about how he managed to do his project. You'll get to ask him a couple of questions as he goes. So without further ado, I'll now hand over the platform to him so he can begin his presentation. Alright, Jose, whenever you're ready.
Okay, good morning.
Good morning.
We have to wait 1 minute so the robot is able to connect.
Yep.
Should I show something this minute?
It's alright. You can maybe start with your presentation slide if you don't mind.
Okay. Presentation slide. Well, I have to say I follow the steps or
Y-
the guide or the project
Um,
with the Robotics. I use the simple factual as a reference to create the other program. Of course, I changed some lines so it is more readable
mm-hmm.
and easy to understand. Mm, 2 seconds. One. Okay.
Alright.
I'm going to connect to the robot.
Yep. Alright, go ahead.
This is the screen.
Yes, we can see it.
Okay. Well, I will run some code to connect the robot.
Mm-hmm. Okay.
Source setup, and I will launch one here.
Alright. Okay, so can we be seeing the robot image? Because
Yes. Here.
yes, that one. Yes, that's the one we want to see. So if you can close the simulation, because you won't need it if you're running it on the real robot, right? We can do that one later. Yes.
Now I will run the job. So if there are any problems, I can manipulate.
Mm-hmm. Okay.
Now the interface. I'm copying it from the right.
Alright.
So I go faster. And when it's ready, I will run the object collaborator.
Okay.
It's the principal program. Open. Okay. This is the second version. And we start to show the odometry. Here.
Okay, may you move your terminal slightly more to your right? Okay, much better.
As you can see, the robot starting moving. It is trying to avoid the obstacle.
Mm-hmm.
Depending on the ranges, it shows 5 ranges: left, front, right, and right.
Mm-hmm.
The program decides where is which is the safest path follow.
Yes.
enough space to decide where to turn, to left or to right, to the longest place.
Okay.
As is right now, and the other cell, the odometry, the distance covered, distance direction, position, location, and the image. Now it should move forward. Yes, move forward because the front range is bigger than the first pole we said at the beginning of the program.
Okay.
Now it is here is smaller than 0.2, that is equal, so it's on the left. Now again turning left because there isn't enough space, and now it should move forward.
Okay.
Yes, move forward. And see this here. The program calculates the space. I show it after if you want.
Okay, let's see the bit you're talking about, and then we can get into the details of the code itself, right? So we're gonna see the base scripts, and then you explain to us why you wrote them the way you did.
Okay. Now or if we go to the simulation?
Let's just go to the simulation and give it a minute or so, just for good measure.
Okay. I will keyload.
All right. You can just disconnect from the robot. Yeah, then you have the freedom to run it.
Okay. The simulation is slower.
All right, so give it some time.
Yes.
Sure. All right.
Again, I will have to set up. And once the simulation does it, I thought it was too slow.
We still have enough time, so I think we can wait for it.
Okay. I'm trying this. We have it here.
Okay,
Simulation.
that's good.
Again, as before, I will run the interface.
Mm-hmm.
And it's Robotics. Direct. Sorry.
No worries.
As I said, it is a little bit slower, but it passes are moving on.
Mm-hmm.
Yes, move forward. And it also shows the odometry. And this cover, current direction, etc.
Mm-hmm.
I think it goes lower because of the FPS, the simulation.
Yeah, maybe.
But this should do the same as the real life, the real variance.
Mm-hmm. Alright, so right now it's considering.
It has enough space. Again, moving forward.
Right. So it still notices there's still some more space to go forward.
Now it shouldn't have enough space. Okay. Yes, it's smaller than the sweet spot, so it should turn right. Yes, right. Because the right is there's bigger space on the left.
Mm-hmm.
And again, because so you see my pointer?
Mm-hmm. You can see it, yes.
Yes. Yes. Turn it right again. And then need to move forward because it has enough space.
Alright, so let's see if it moves forward.
Front left, no. Enough.
How did you determine for how much it is to turn? Like, did you do any form of calculation to determine how much angular distance it's going to cover, or
Yes.
how did?
When it's going forward, yes.
Okay, what about when it's rotating in place? How do you control how much it rotates? Do you use time, or do you have a certain type of algorithm that tracks the angle?
I said velocity, angular velocity, and the time. Yes.
Okay, so what time do you use for every rotation?
1.5 seconds.
Okay, all right. And can you explain a little bit how did you choose that? How did you end up at 1.5 seconds?
I can show you in the code if it's open.
Yeah, it's all right. Let's go into the code so we don't dwell on the simulation. I think we've seen that it manages to avoid the wall. That's good enough. So let's see your code, and then you can be explaining these details.
So you can stop it all. Code.
Yeah, it's fine. You can stop it. Yes.
The code. Okay. I explained before the obstacle avoider is conversion. I define some functions, as I said, because I wanted to be more readable
Mm-hmm.
to understand. So before we have the functions, I define the getters
Mm-hmm. Mm-hmm.
and the setters.
Okay.
Here, the obstacle avoider, we have the check range that has three arguments, three entry arguments.
Mm-hmm. And can you explain to me what those arguments are?
Yes, we have 8 possibilities, 8 cases.
Mm-hmm.
I thought it like that, 0, 0, 0, 0, 0, 1, and so on. These are the entry arguments, and we compare them with the variables. The variables we obtained before at the getters.
Mm-hmm. Okay. All right. So you're getting laser scan data, but okay. All right.
I don't know if I can share the slide.
Yes. Yes. If it's going to add a little bit more detail, yes, please do.
Okay. Can you see it?
Yes, we can see it. Yep.
This was the program before, the first question, and I thought it was clear, more clear like that, to show the free space on not free space with 0 and 1. You can see both ROS and slide or only only one.
We see only
Only the slides. Okay.
yeah, only this slide. You'd have to move to the next one for us to see the next one, or you can
Okay,
switch to the browser. Yeah.
next here, and next we move to the ROS project.
Okay. All right.
This function to check the ranges, and also the turn left, turn right, and not the move forward function that doesn't appear here, but it is like
It's exactly like this. The
yes, it's to be more simple.
all right.
Here
All right.
an example, or it decides to turn left or turn right depending on which range is bigger. Here we can see it only says turn left or turn right. It's easier to understand what it's doing than seeing that this we have on the left.
Okay.
We go back to the ROS project.
Okay.
Here. Okay. So we can see turn left, turn right, and the move forward. It is a little bit more difficult because it has to calculate the distance to move, time to move, and we calculate the time to move because it may have some delay.
Okay.
So we subtract 1 second.
All right. And how did you choose 1 second? Was it just random? Did you have to try other values before you got to 1?
It's random.
Random.
Yeah.
And it worked on right from the beginning?
Yes, yes, it was the first value I tried.
Okay. All right. All right.
Because I thought it was simple enough.
Okay.
I didn't cause any trouble with the threshold.
Okay. All right. All right. And your threshold value, what is it?
Here.
Okay, 0.3. Okay. All right.
And here the initial conditions to assure the robot is stopped at the beginning. And now the while, that is something that is always executing. It checks when it gets the values, so then at the serve, then it checks if every one of them is free, not everyone, only front left, front, and front right, and then it decides what to do. If move forward, turn left, or turn right. You can see all here. We're calling the functions on right, and forward, check range. I can show you the statistics.
Yeah, just hang on 1 sec on the obstacle avoidance. So, can you explain to me? I see you have check range and then you put 110 or 010. Are you using those as Boolean values? So, like your 0 being not free and the 1 being free. Is that what's going on there?
Yes.
Okay, I see. I see.
That's the comparison.
I see.
If it's true, it's set to 1.
And
is set to 0.
Okay.
Value.
Okay. All right. So let's go to the robot statistics and then we talk about that one as well.
Okay. It's more simple. It's only show it gets value and it shows the echo at every value specified at the guide.
Okay.
Yes. With enough space so it doesn't collapse all in one.
So I've got odometry orientation, angular velocity. Okay. All right.
Yes.
All right. All right. That's good. That's good. Okay. Can you go one more up? Okay. Right. This is your getter script. Okay.
Yes.
All right. So can you? Okay. Now I'm gonna start asking you a couple of questions about some of the things I've been noticing. Right. Okay. So first of all, I'd like to know. Can you explain to me within, let's say, the getter function get command velocity linear, right? What is the purpose of AWK? What does it do within base scripts themselves?
This.
Yes, can you explain, yes, how it works?
This extracts the value of the post argument.
Okay, all right. And on what basis? Like, what's the criteria of separating the arguments?
The arguments.
Yes, how does it know that this is the end of the first argument or this is the end of the second argument? Like,
Has some spaces between.
all right, all right. Okay, that's pretty cool. So let's go to the obstacle avoidance script.
Okay.
Now I want you to explain to me what's going on after the pipe operator, right? So we see that, for example, if we take the front left free, the function that does the checking, right? So after the pipe operator, can you explain to me what does BC mean and what's the significance of stroke L in front of it? I think I lost your audio, your Jose. Can you?
Are you referring to this?
Yes, that's what I'm referring to. Yep.
Linux, when it does its calculation, it considers the numbers as integers, not as 12-point numbers. So, like this one. So, if we want to be more precise with calculation,
Yes.
we have to call the basic calculator
To allow the computation of floating point numbers. Is that what you're saying?
Yes.
Okay. All right. All right. All right. Okay. So now I want you to go into the robot statistics script, right? And that one. So just pick, let's say, robot orientation, right? Can you take me through the logic of determining or getting the value for robot orientation? Like, what is happening there? What computations that we have to do? Or you're just getting values as they come from the robot interface.py?
I have to call the echo to show the message on the cell. Then I call the function get column. The query gets, because the function, let's say, here.
Okay, all right. It calls that one.
Of this, and then it gets the value of the post argument. And when it gets the value, it's not a float number, it is like a string. So we have to put it between the brackets and add this to state that it is a value, not a string.
All right, all right, all right. All right, Jose. Thank you very much. Wonderful presentation. So, congratulations for taking us through the project the way you did. So, so you just hang on and we'll look it up. Okay? All right, everyone. This was Jose's presentation, and a warm congratulations to him. I'd like to thank him for taking us through the details of what he did and why he had to do that. So, without any further comments on that, I would like to congratulate him and also encourage all of those of you who would want to come and also give your presentation, showcase what you have done on all the courses that we offer certification on. So until next time, keep pushing your ROS learning. Bye bye.